Hi, my name is Adam Davis, and I wanted to give you a look at my thermal grill illusion.
It's a lot more.
Okay, so this is my thermal grill illusion prototype. It's pretty rough. I just wanted to prove that the two Peltier devices that I'm using and the aluminum bars and the design that I chose actually produce the effect, the desired effect. So the thermal grill illusion was discovered in the late 1800s, 1896. And the idea is that if you have a set of cold bars and a set of hot bars alternating, then placing your skin on it will produce a burning sensation, a painful burning sensation, even though the hot bars and the cold bars separately are not harmful at all. So here we have a Peltier device in between the bottom heat sink and this plate. This plate is currently cooling off, and it's cooling off of these two bars on this side. There's a temperature controller here that's controlling that Peltier device. The heat sink is shared between the hot and cold sides, so this Peltier device is currently warming up this top plate. Here's a temperature sensor for that. And that way the heat flow moves from these bars down into this heat sink and then up into here. It's a little bit more efficient than separating the heat sink in the middle, but Peltier devices generate a lot of heat. So there's also a fan back here to cool off the main heat sink, and that will turn on in a moment, become a little bit louder. You only need to have a temperature difference, in this case 40 degrees Celsius, which is about 104 degrees Fahrenheit, and 20 degrees Celsius, which is 68 degrees Fahrenheit. That's sufficient to produce the illusion, and we are already there. So this, on my hands, it feels really uncomfortable. It's not terribly painful. The hot side is cooler than my showers, and the cool side isn't even cold. I mean, 68 degrees just isn't very much, 20 degrees Celsius. But if I place my wrist there, it is very uncomfortable. I really don't like that sensation. And I think that has to do with the density of the nerves and the areas of the skin. Now, this is very simple to make. We've got a 150 watt power supply, and this is about to turn on. I'm going to go ahead and turn that off so the fan doesn't come on. In fact, I'll just turn the whole thing off. 150 watt power supply. The two Peltier devices that I have selected are only 40 watts apiece, so there's only 80 watts here. I could go ahead and overload the power supply and have 4 sets, but that's irrelevant. So, it works, and I just bodged it together. I didn't really put any time into flattening the aluminum surfaces. There is some heatsink compound in between each of the surfaces, but there's 3 layers here, and the heat transfer is still sufficient to give me cold, hot, and then produce a sensation in the middle. And it was built largely from a beverage cooler that had 2 sides, 2 Peltier devices, and a heatsink and a fan. So, fairly straightforward. You can get aluminum heat sinks fairly inexpensively. And then, the top plate is 1/4 inch aluminum. There's a spacer of 1/8 inch aluminum, and then the bars are 3/8. Now, all of the papers have about 10 millimeter bars with a 3 millimeter spacing. 3/8 inch bars and 1/8 spacing is fairly close to that. I would like to experiment with closer bars to find out if I can trigger the same sensation on my hand. I mean, this is uncomfortable, more uncomfortable than touching over here or over here. So it's there, but not as definitively. But it would be interesting if I made the bars thinner, if that became more painful, or if, for instance, children became more sensitive to it, because their nerve density is even more than an adult. So I'm planning on doing a Kickstarter this summer. I'm going to show it off to a few local museums. I'm going to make the surface areas much larger, use several more Peltier devices so that we can have a museum quality display. But even then, it's still going to be fairly small. fairly portable. I ran across this several years ago, and they used a small refrigeration unit to create the hot and the cold parts. It was very large, it was loud, and it must have used quite a bit of energy, but the sensation was very strong, and that used 1/4 inch copper tubing, and the copper tubes were fairly close together, so the spacing was actually much closer than this, even though this is what the researchers use in their various papers. I'm going to experiment with that and find out how far we can take this. So I'll be doing a Kickstarter, and the Dune paint box started popping up in my feeds this last week, and I thought, okay, I've really got to get this done because I've been sitting on this for years. I've really been wanting to do this, but here it is. So I saw the Dune paint box and said, you know, I can do that, and I'm going to do a Kickstarter this summer. We'll see how it goes. Give me a holler on Facebook or Twitter or email, and if you're interested in if you have questions, if you need to figure something out that I haven't explained here, and happy making.